whatever devices at the nanoscale. Um, so that's interesting. So if you guys, want to do some further research on the nanomaterials, you need to read more instead of just um, continuous mechanics or mechanics of materials from the uh, micro up to the meso or macro, size. Uh, Another thing, for the assignment about the softening. Um, Actually, that's like I mentioned this noon that the recovery and recrystallization is are the way, people talk about the softening. I mean, just it causes the softening of materials. And so recovery, we can divide some recovery and dynamic recovery, or recrystallization and dynamic crystallization. uh, it depend very much on, the condition of working, forming, forming, like at room temperatures or at high temperatures. And for recovery, it's a process by which the deformed grain can be reduced, their store energy. So sometimes they call recovery as like restoration, or softening also, like we call a restoration process. Um, and in, the recovery, uh, the dislocation, uh, you know uh, generated by plastic deformation. I mean, that's during the plastic deformation, so the plastic increase, I mean the density, right, of the dislocation. So so that's why it increased the year trend. So, in recovery, reduce the dislocation density. So it also means that we can reduce the stress. I mean the strength of materials. Um, and recovery also sometimes, when you research on the materials, you will know that the recovery related to the similar process like recrystallization or grain growth, um, or also like in some heat treatment way, like annealing, okay, aging. You can see that's the first stage of the heat treatment processes. Um, and for the dynamic recovery and dynamic crystallization is normally, occur during the formation at high temperatures. And remember that the dynamic recovery or recrystallization is occur during, the hot forming kind of, yeah, like rolling or extrusion or forging, at high temperatures. So we call hot forming. Hot forming. Do you know that the condition of temperatures for the hot forming? What temperature we call hot forming or hot working? How to define that's the cold working or hot working or warm working? Do you remember? Can you hear me? Or internet problem also?
Uh,
Yes.
the is hot or cold working depends on the temperature is above or below the recrystallization temperature.
Yeah, sure. Yeah, right. But like for steel, do you know exactly the temperatures as compared to like melting point?
Um, 2/3.
True that? Really? Sure. Anyone have another idea? Or...
Or a half.
Okay, normally for recrystallization temperatures from 1/3 to half melting temperatures normally. So it depends very much on the materials and also the working condition, because sometimes for some materials the recrystallization occurs at very low temperatures as compared to the theory, like 1/3 or 1/3 or or half. So of course you have to do the experiment and then to observe the microstructure to find out that's at what temperature or what condition. On only the temperature is okay, but sometimes um, the recrystallization temperatures it depend on the strain. Yes, like at how many percent of deformation. Uh, so yeah, like aluminum, that's like 10 years ago when I did some experiment on magnesium and aluminum, I find out that the recrystallization occur even at very low temperatures, just like uh, around 1/4 kind of. Yes. So yeah, it's very interesting. That's why we call material. So I'm very happy to know that all you guys already attend some like lab to do research to find out some good thing, to discover new thing, and of course each time each material has their own property and own interesting things. So okay, anyway, hmm, um, and do you know that? We know that the recovery can reduce the dislocation density. Do you know that's why recovery process can reduce the dislocation density? Do you know why? Hmm. Any idea? No idea. Okay. Yes, I can talk a little bit more about this. Uh, because uh, the rearrangement of the dislocation, and also like the inhalation of the dislocation. Yeah, you remember that when the deform generate a lot of dislocation, right? And location react, and some temperature, some dislocation, they annihilate. Do you understand? Like in Vietnamese, like uh, những cái lệch trái dấu thì nó triệt tiêu ấy. Có nhớ cái đó không? Hello. Nghĩa là những cái lệch mà nó cùng dấu thì nó sẽ cộng hưởng lại, còn những lệch trái dấu thì nó triệt tiêu. Khi mà cái density nó rất là lớn như thế thì với cái năng lượng thì nó, nếu như những cái lệch nào mà nó trái dấu một cái âm và cái dương thì nó sẽ em có nhớ cái ô mạng không? Hay mà nó khuyết tật một cái defect, một cái những cái ô mạng mà trong cái hôm trước chúng ta học về cái sliding. Sliding thì nó có một cái ví dụ nó có một cái lệch nó theo lệch trên này xuống là lệch dương ha. Xong là trong quá trình nó move thì nó có một cái lệch ở dưới này lên âm, thì hai cái lệch nó khớp lại thì nó lại thành một cái ô mạng hoàn chỉnh, thì nó gọi là nó triệt tiêu nhau. Có hiểu không nhỉ? Thì nó giảm cái mật độ lệch xuống. Ok. Ok. Thì cái thứ hai nữa là nó rearrange. Thường recovery là cái nó giảm, nó đặc biệt là trong quá trình hot forming ấy, thì được cấp thêm một cái năng lượng. Thế nên là khi mà biến dạng thì thường là các cái ô mạng nó bị lệch. Thế thì và các lệch khi mà nó ở trong đấy, khi mà nó rearrange lại các cái ô mạng thì nó cũng giúp cho các cái lệch nó có thể move, di chuyển một cách nó nhẹ nhàng hơn, nó không bị vướng phải những cái khi mà mình xô đi thì nó va vào những cái như chúng ta học trong cái đọc trong cái slide mà thầy có gửi về cái nó gọi là grain hardening by reduced grain size, như là cái hạt nó nhỏ ấy. Thì cái bài mà cái lệch nó tích tụ lại thì nó các cái biên tạo các cái góc lại, các cái góc trượt khác nhau ấy, các góc biên hạt, góc biên hạt. Cái góc biên hạt nó lớn thì nó khó nó di chuyển. Thì cái này khi mà nó rearrange trở lại thì nó sẽ giảm được tất cả những cái đấy đi, để giúp cho những cái lệch nó có thể di chuyển nó dễ hơn, thì nó sẽ làm giảm cái ứng suất xuống. Okay, for assignment, so is that enough for assignment, right? Any question? Hello. Hello.
Hello.
Oh.
No.
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 Type
question.
type 0 if you don't have any question so far on the Hopek equation and the softening, please. 0. Okay.
I wanna ask something.
Okay, go ahead.
With Hopek equation that we have, the D is the average diameter of the grain side, and I wanna ask that if the grain size is different, had a large difference, so can we use the Hopek equation?
again, if what, if material has what?
If the grain size
Yeah,
has a, a large difference in the diameter.
you mean that's unhomogeneous, right?
Uh-huh.
Inhomogeneous, right? Like some grain big, some grain small, right?
Yes.
You mean that, right?
Yes.
Not normally we can use. Normally we can use a Holbrook equation. Of course, I mean that's uh, larger than nanoscale, okay? But it's right on. I mean that's the result. The result is correct. I mean that's precise or not. We have uh, to calculate many times, and then also to get the average one. And I would like to mention to emphasize that the Herbeck equation just for us to predict something, not to use a result for the to using for for calculate the strength of materials. Okay, you got it.
Okay.
Because you know that if you want to get the yield strength, you just do the tensile test, right? But here's the sometime for us like to predict or to see the trend of improve or uh, increase or decrease the yield trend, by the reduce grain size. Okay.
Okay.
Okay, thank you. All right, so okay, so uh today I would like to talk a little bit more about the hardening, as I mentioned before. Um, One of the way to improve the strength of materials is particle hardening, or sometimes we call like precipitation or dispersion hardening. It means like in Vietnamese, like the precipitation is mean tiết pha, right? Or disperse like phân how say phân tán gì đó. Okay. Um, so dispersed particles can increase the strength of a solid by impeding the dislocation movement. We know that sometime like uh, particle, we put some more uh, uh, before we study like what is uh, like alloying, right? Like somehow like alloying, you put solid solution. Yes, solid solution. Yes, kind of. It's the same phenomenon, same mechanisms. But here we don't put anything. But during the process, it's the material, precipitate, a particle, and this one prevents movement of the dislocation. Um, um, so can you open the slide that I sent you? Because I cannot share you because now I am using the mobile phone. So the mobile, I saw the mobile. I don't know how to share the file via the mobile. Okay, who do the research with Dr. Professor Khánh, the two Khánh, right? Not Mr. Beer, uh, Mr. Big Belly.
Tân.
Tân, Vice Dean of the school, material school. Tân, are you there? Tân, eating dinner, chatting with friends, playing game. Hello, Tân.
He doesn't attend the class.
I saw him here. Okay. Well, anyway, okay. Because I just want to ask questions. It's how many people are familiar with the precipitation. Is that like you read about that, or you do research about that? Hello. Oh, how to interact with you? I keep silent like this. Sometimes the silence is not golden at all. What's lie? No, the slide I off this morning. The 30. Uh, yes, right. Yep, right. Yep. So none of you read the material before, right? None of you. None of you read, right? Okay. So I give you like 5 minutes, just like a scan reading, uh, to see and try to write down some key point of zip method. Or like in the examination, we will have a question like this: how to improve the strength of materials by um, particle hardening method, kind of. So right, as I told you, that's the particle, can be, precipitate, real natural, or they can also be things like dispersed, like oxide or or carbide particles. So we are, not natural, right? It means that sometimes it's from inside the materials, so it's precipitate. But also we can, put the oxide or the carbide, particle inside materials. And um, and of course, like solid solution methods. So the particle, be the barrier to, to prevent the dislocation. So um, if the dislocation want to move, I mean this, if we want to deform materials, the dislocation have to, there are two ways, to move. One is they can, cut the particle or shearing, right? Another thing is they can choose between the particle, and if you are, the boring or a organ looping. Organ is a scientist. He creates some theory, not only in the looping, issues, dislocation issues through, the particle, but also he proposed some theory on calculate, the toughness of materials, for brittle materials, and we will, talk more when we study about fractures. So remember there are two ways the dislocation, to have to overcome, the particle, um, if we want to deform the materials, of course, right? Because when we deform as the first stage, it's very easy, because the dislocation just move. That's when they get the particle. So the hardening, occur. So if we apply the force more and more, so there's two way, the dislocation, when um, overcome. One is shearing or cutting, the particle. You can see, on the slide. And second one is issues, we call it looping, like in slide. So they also propose some equation to calculate, the shear stress, in this case, and in the equation in next slide, we can see that's the sliding modulus, and also the Burgers vector, and L is the distance between two particles. Uh, so yes, so it depends very much on the type of the property of particle, and also the particle distribution, so they can calculate, the value of shears, that make, the dislocation continue to moving, continue moving. Um, and at what condition, appear the precipitation. So you learn in the physical metallurgy or thermodynamics, you know well about that, the phase, what condition about the temperatures, and the percent of weight of the, alloying, so phase alpha beta, so that what, condition, so the materials will precipitate some, like some particle, So like here they point out for three type of precipitation. um, Small particles generally coherent with the matrix, and intermediate particle often semi-coherent with the matrix, and last particles are generally incoherent with the matrix. um, and the next slide is demonstrates in the crystal matrix of materials with the small inside and medium and the big. Um, Another factor to consider when the particles are coherent. In some slide, you can find out that's we call like the modulus of hardening. So as I mentioned before, that we have to calculate the shear, the maximum shear stress. But one thing is I would like to emphasize that the value when we calculate following by some equation like it is much smaller uh, than the fact. So people try to explain that's why when we use some this formula to calculate the shear stress, they felt that it's at the very low temperature, low value. The you know the dislocation can cut or can uh, over the particle, but in the reality it's not easy like that. So the reason why um uh, that is the one of um, the most simplest way to approach the study about the fractures, um, because that's in the reality it's not difficult to break uh, materials, but for the theory, in order to break the materials we need to put a lot of force, a lot of energy, because just the sliding modulus very very high, very high, like 10 times as compared to the reality. So some scientists they tried to figure out what's going on, and they find out that's because of the defect of materials. We will talk later when we discuss about the fracture. But again, like we calculate the Hopek equation, that's sometimes we calculate here just like uh, we try to see the tendencies and a value that's just for the referring, not for using to apply when we design a structure kind of. Here just like referring, when we do research we see the tendencies and uh, try to compare at what condition it improve or decrease or increase kind of. um okay, so for summary of hardening and channeling mechanism for crystallized solid, you can see in the table in the last slide. We have like work hardening and grain size, opaque, solid solution, deforming particles, non-deforming particle, and we also have the nature of optical, strong or weak, and the hardening law. Hardening law is means that we use this kind of equation to calculate the shear stress. Um, it means that's adjust that value, that shear stress value. Um, it's the maximum of to make the dislocation can move, or the material can be deformed. Okay. um I have assignment for you guys, but you have to divide the class in some group. So totally you have 11, right? You have 11, right?
Actually, we have 12.
12. But I see just like 11 attend the class. Okay, okay, assume that 12. So we will make well 4 group. Okay. Okay, 4 group. Okay.
Okay.
So 4 group. Yeah. Tammy will help me to divide. No, 4 group. Okay. So first group will uh review about the work hardening and take some example. I mean that you can find out any materials or any document or textbook, whatever. You will take one example with the namely materials that can be applied that method to improve the strength. Okay. For example, for work hardening, you review the theory and the mechanism, how to make them, blah 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 blah, and then give one example. Like you can find some journal or some like um, paper, scientist paper, to do research on one thing. You can review that they use this method to uh, improve the strength of material. Okay. And second group and um, solid solution. And the third one about the um, particles hardening. Okay. And the final about the grain size. Okay. Clear. One group can work on work hardening, one about work on the solid solution and particle hardening and grain size. The same format. You will review about the method and then take one example, because you know that some material you cannot apply all the method to improve the strength. You just can use one, like just one is solid solution. You cannot use work hardening, or some material you just can use work hardening to improve the strength, or you cannot use like disperse or precipitate. Okay. It depends on the temperature, the materials. So that's why it's interesting. It's also like the behavior or the strength and the weakness of a pupil. Like when you study like a subject, each people have their own method to get more knowledge. One is study hard, one just reading, one is watching video. It depends on the way you feel that you can get more and more knowledge. So the material is the same. They behave like people, human. Are you clear the assignment?
Yes.
Yes.
Okay. So the next time each group will have 20 minutes, okay, to present the method. And remember, let's focus on um, the example. Okay. Any question?
No.
No. Okay. And uh, I still see some member have not submitted the assignment yet. Here they say like late in 1 hour or blah blah blah. So what wrong with you guys? It's like Phạm Quang Vinh and Trần Hoàng Anh and also Nguyễn Đức Mạnh. Don't forget to submit because I will use assignment to give you the process grade. Okay, so Jamie, can you help me to to put the name of a group, okay? So that I can know just which one belong to what group
I just put the link into the chat
already.
box. Yes.
Okay, thank you. Okay, so can we finish now? Hello, or you have any questions? What question? Any question is okay.
We have no question.
No more question.
No.
Oh, okay. So type 0 if you have no question, and we will stop now. Okay, so cool. Okay, now goodbye. See you next time, and good night also.
Bye, teacher.
Goodbye.
Night night.
Thanks. Bye bye.